Okay, so I've been trying to make this tutorial for over 24 hours. I tried doing it last night. It was too busy. I tried doing it this morning, and people kept emailing and calling in the middle of the recording. I have my fingers crossed that we will make it through this time. So this tutorial, actually, there'll probably be a couple parts to this. The question in class was how to draw a shape of multiple sides, a triangle, a hexagon, whatever it might be, a very rough circle, a diamond shape. So the whole idea was, how do you create points, maybe around a center location, I guess, to create this. And in class, we've already looked at just how to call out triangle that has its own functionality, and certainly we can draw a circle and rectangle. Some of these other shapes, processing doesn't have, right? So you need to kind of do this by hand, and we're going to look at that. But to do this efficiently means that we have to go into scary land. We need to look at trigonometry. So don't turn the tutorial off. We're not going to get into a bunch of equations. There is an equation solving this, but there are really good tutorials out there to talk about that. I'm going to try to stay away from that and just look at the functions and talk about the concepts of what's happening in these functions and how you can use this to give you angles and a distance to create some of these shapes that we've talked about. Okay, that's my setup. The sidebar to this is knowing that I needed to draw some things on the screen and not wanting to set up like a separate whiteboard or multiple video cameras, I needed something to draw with. And so I did add some code. Actually, most of it's hiding down here. But I created a little function that I'm calling grayboard. It's like a whiteboard, but since open processing starts with this gray background as a default, you can see that I can draw. And so I set this up so I could toggle and clear because I need to be able to draw what we're talking about. So I only wanted to mention that, so if you're looking at some of these variables and some of these things that you are not familiar with, just ignore this, ignore these things, ignore that. Ignore this code that I put way down here at the bottom. That's all about just being able to draw to illustrate what's going on. Anyways, so let's talk about the problem itself first. So when we create a rectangle, in fact, we create a circle, right? This is very easy. We just say, hey, this is the X and the Y location. This is the center, and I have it right here, width and height. And then processing already has a function to draw this circle, the points that go around it. So it's kind of hidden from us, and it does it for us. When we draw a rectangle on the screen, right, all we have to do is tell processing this point if we're using corner mode, and then we tell it what the width and the height is, and we get some kind of rectangle or square. And when we do those, in fact, let's imagine a point here, right, in space. So if that was going to be the center of a circle or corner of a square, it doesn't really matter. But to get this point, we use something called Cartesian Coordinates. We did that for the other examples a second ago. We figure out, well, this point is so many units to the side, right, along the X direction, and then it's so many units, or pixels in this case, right, down here, and this gives me the X coordinate, and it gives me the Y coordinate. So that's fine, right? Let's clear that. So let's imagine, what if I wanted a point here, and a point here, and a point here, and here, and here, and here, to draw some kind of shape like this, right? I made that last line a little wonky. So you get the idea, right? So I'm making this six-sided shape. Well, this would be kind of difficult, though not impossible, to say, well, I'm going to figure out this point here, and then this one will be like that, but it's down here, and this one would be back towards the center. So in each one of these, I have to figure out how to draw over and down, and over and down, and over and down to get this one, and over and down. And I'm doing these in order with the idea that just how processing would draw a shape. I'll talk about that stuff later. Right, so that's a lot to figure out as far as those components, and this is just a simple shape. What if it was going to be a point here, and a point here, and a point here, and a point here, and a point here, so that we were making an arc, right? A kind of a perfect arc. That would be a little more difficult. Like, what's the rate of change between this point and this point and this point and this point and this point to this, right? How does that work? So that's the Cartesian coordinate. What we're going to use is a set of, we're going to use polar coordinates. And processing doesn't naturally use polar coordinates, but we can use some math, the dreaded trigonometry word, to help us figure that out. And when we use polar coordinates, we start with kind of the idea of XY coordinates, and we'll just start with it here. But really what we need to do is we can start with an angle, and that angle can be expressed like this as far as the drawing, right? Rather clever how I put my little circle there. Right? So this angle is measured between this kind of starting base and then whatever the difference is here. And then this length here, so how big this is the radius. Okay, so it's that length of that. So we can easily do that. Processing has some, the polar coordinates work that way, and processing has some tools to help us do this. We can set this up. But because processing uses XY coordinates, when we create these points that would happen every time, say, we create a new angle, right? We figure out this point, and this one here, it's like a spoke, right? Spoke of a tire. Right, so each one of these, it would be a certain length. And of course, we could change this length. The example maybe given in a Dan Schiffman video that I'd seen is you could make a spiral, right? By making this arc, but just changing the radius here as we go along. So anyways, let's go back to this. I digress. Right, so this is this angle. So we know what the angle here is, and then we know what this radius, or we can define what this radius is. Maybe it's 100 units. It actually would be more than that, since I can already see that this is set at 100. Though I think this is the diameter. So how do we go about, and what is it that we need to solve? Or what is it that the processing's functions are going to help us solve? Let me clear that again. So this is the angle. We're going to pretend this has that radius, and there's we're trying to solve. This is where that angle is. But what we really need to know is this and this to figure out that location. So how much to the side and how much up? And then, of course, if we did another example here of that, then we would come over this far, and we would go up this far. We could do this all day long, right? We could say this is an angle, and I need to go over this far, and I need to go up this far to figure out what that is as I complete, if I was just going to make an arc that all had the same radius to it, right? So the trigonometry, the equation, I'm not going to get into that, but we have functions that help us solve that amount. And so let's go to the P5 site. Oops, I already saw it, and I want it right there. Down to the bottom. And I went right past it. There we go. So within the trigonometry, we have this sine and cosine. I'll click on that here. And I'm just going to read the description. It calculates the cosine of an angle. So if I went to the other, let's go back. And if I clicked on the sine, it calculates the sine of an angle. And so the terms used to define this within the math that's going on. But really what it is, it's figuring out this, and it's figuring out that in our sketch. So let me clear that. And the cosine and the sine are really helpful for making, in this example, we're going to make this shape, but you can use it in lots of different ways. So a the other thing I mentioned here is that it says calculates the sine of an angle. So that's the number that we're going to put in here is what that angle is. So anytime in processing when we talk about angles, we're talking about degrees, right? 90 degrees, 180, 270 degrees, whatever it might be. Processing thinks in this thing called radians. Don't even worry about it. Just anytime you hear the word radians, just remember that Dane told me forever and ever, as long as I'm doing coding, is that I should just, if I hear this in P5, I should use this function. This handy little function that we put at the beginning that says, you know what, instead of calculating in radians, which we all don't even know what that is, we're humans, we're used to, and not mathematicians, we're used to degrees. So we're going to use angle mode and degrees. And I'm going to create, I'm going to use that function, right? So we had a function here called sine. Oh, in fact, let's go back. It's just use cosine, doesn't matter. You can use one or the other, which you will see here in a sec. So I'll just use that. And I'm going to put in fact, I'll put 0 in there. So it asks for an angle, and I'm doing them in degrees. So 0 degrees is what I have put in there. And then I'm just going to say print, actually what I want is a variable. So let's say let x equal whatever this cosine is. And we'll put x in there. And down here at the bottom, I'm just going to say no loop. So it just does this once for now. All right, so I told it the angle is in degrees is 0, and cosine, it sent me back the number 1. Interesting. Let's put 90 in there. Gives me this weird number, which actually I think is a little bit of an error. Let me try 180. Okay, so if, depending on where we start counting, but if 0 degrees was down, or maybe it was here on the side, 180 would be the complete opposite, right? So 0 degrees was 1, 180 was minus 1. What if it's 360, which would be the same angle as 0? Oops, didn't mean to hit return there. All right, so I get 1 again. Let us consult the reference. Maybe you read ahead, so you saw where I was going. Values are returned in the range of -1 to 1. So a lot of times in some of these functions in code, because it doesn't know how much you want to do something, a lot of math functions are condensed down or normalized to return a value between 0 and 1 or -1 and 1. So we can still solve this if I went back to my little processing sketch here, and I would draw, oops. There we go. What's going on here? Let's draw a print. I broke my, I turned on no loop. Duh, sorry. See, you do one thing, messes up with some of the other stuff. Okay, so you can see now I can draw inside here. So the so when I figure out these angles, if I figure out this much up, and this gives me that angle, or we're doing a reverse, right? We give this angle, and I figure out what this distance is. Well, if the magnitude of that radius is that long, or that long, or that long, well, each one of these lengths here have to be different, right? That's a little baby one. So what processing does, and a lot of math does, says let's just pretend that we're only going to make something that has a radius, a total of 1, or in this case 1 -1 on the other, to give us the other side. And if I want it to be bigger, then I'll just say this times, 200. Oops, and it's just counting along there. So you can see it takes 1 was what 360 was, what was a 180, right? Minus 1. So it gives us minus 200. So this little thing's just going to give us a number. We put an angle into it, and it says, take the degrees, do your fancy math, and give me a number between 0 and 1, and then we're going to multiply it by whatever I think the radius is. So what I could do here is I'm just giving a number that could go between here and here, right? Imagine these are exactly the same length. That each of these is 200. So we figure that out. That gives us one side of that triangle. That's the cosine. If I did sine with it, I could also figure out how much I want to go up this way or how much I want to go down that way. And that, so if I define that angle, it will help drive how long this should be and how tall this should be. And it will give me this point right here. Crazy, right? Okay, so let's just look at it in a practical example of, you might be thinking, well, I don't want to draw any shapes, Dane, so this is not relevant to me. Trust me, you do want to use this. So let me comment out the print, and let's take x and just put it up here. I'm still going to print x, actually. I think that will be helpful. And actually, this is going to get a little complicated, but let's just put x right there. What did I do? Where did I put it? Oh, minus 200. So what I've done is I've moved this off the side of the screen. So really what I wanted to do was width, and I intentionally want to do it this way actually so that you would see something else. So I want to say be in the middle, and you can see it moved it over 200. And right now I have this, I put 180 in here. I'm going to create a new variable. Let angle equals 0. And we're going to put angle in here. So right now it's going to be 0 or 360 degrees. Remember, we're both all the way over here. So print x would be 200. So 200 plus whatever the width is. But really what we need is angle starting at 0 to be equal to angle. And we can make this any number, but I want it to happen kind of slowly. So I'm going to say 0.1. So it's nice and slow. Not plus. Angle is going to equal, and I'm doing it the long version here so that you can see it, equals angle plus 0.1. So it just continues to grow. Right? And you can see the numbers down here driving the position itself. You can see it's happening very, very slowly. I'm not going to wait for this to make the full way. I just wanted you to see that these numbers, so if you want slow motion, so it's like a pendulum, right? The numbers themselves are based on the angle, they're kind of spinning. If you write that the angle is going around to drive this, we've just flattened it out so that it's moving back and forth. It's kind of like one-dimensional rotation is the way I sometimes think about this, right? So it's just moving across. So let's create another variable. And let's say y equals, so we're going to do exactly, this is the nice part about that, is if you figure out how to do it for one, you can do it for the other. So now let's say the height divided by 2 plus y, and maybe to help so we can see this, I'll turn off the auto format. So the width divided by 2, I want to start in the middle, and I want to get so that's the base position, right? So this is going to be my home position. And then I've made the circle just 100 units here. And then I'm going to figure out x and y. And with doing this with x and y, it's going to give me some number between minus 200 and 200, because the cosine is going to give me some number between minus 1 and 1, and then 1 times 200 would be 200, right? 1 times minus 200 would be minus 200, or anything in between there. So, and these two functions kind of work with each other based on that angle. So now you can see I've created a very nice circular, rotation across the screen, right? And I still have these numbers just going crazy. They get all the way up to about a minus 200, they get all the way up to 200, and then they go back down, right? So they're just ping-ponging back and forth. But inside all of that, some angle is being figured out based on this trigonometry, these triangles, okay? So let's, the other last way I'll say, boy, this is going to be a long tutorial, but this is a complicated subject. A lot of time, the way I'll see this put together is for x and y, we'll just say the width divided by 2, or it could be anything. So in fact, I'll do that, width divided by 2 plus this cosine. So I don't need this anymore. And let's just cut that, paste, and plus that. So if you remember nothing else, just remember in trying to solve this trigonometry question of when you're going to spin this around. So right now we're just spinning it. In the second part of this tutorial, I'm going to draw shapes with it. We're going to start with this. What you'll see is whatever this position is. I could make this like 100 by 100. So that's part one. This is kind of like home base. And I'm going to add to that this little bit of math, right? Whatever that sine or cosine is between minus 1 and 1, multiplied by whatever, the radius is. And this could be different. In fact, you can figure this out, actually, if you want them to be opposite of each other. So it's going off the screen here because I've centered the pivot over here at 100 by 100. I'll just put that back where it is, probably easier. But I just wanted to make the point that it doesn't always have to be the width divided by 2. This is just to put it at the center of the screen so that we can see the motion. All right, so now I get this nice elliptical motion happening because the sine is twice as long as the cosine down here. So it's stretching the solve for, so it's basically I'm solving from side to side and up and down, and that's figuring out the two sides of the triangle that are giving me an angle to where this location would be. It might sound complicated. We're not even going to pull the math equation out, but just looking at that, or just thinking about it conceptually this way, hopefully this makes sense. I'd probably do like 10 different tutorials about trying to explain this concept, but let me try to recap. Polar coordinates, so they're going to help us make these shapes or motion that happen with angles, usually around a center point. And to do polar coordinates, we have to do some trickery using some trigonometry, which are hidden in these little cosine and sine functions, to give us some numbers where we can figure out the Cartesian side, the x and y, right? So these are the Cartesian ones saying, will you figure out your polar coordinates and give me back the answer? And then I'm going to use this to do some really cool animations or some cool shapes. The last part of this is, again, we're putting the angle in here, and that's what this is. We're feeding a bunch of numbers in here that are driving the angular motion of this. And we've made sure that we're using degrees because that's the easiest way for it to think about it. I put these two parentheses here on either side to give you a sense that this is the formula and this is the part we're adding it to so we can figure out where this goes. Maybe the last thing I'll do is mouse X, mouse Y. So again, these are just these locations themselves. And you can see that it's doing its orbiting around whatever that center point is, right? So my cursor is that first mouse X and mouse Y, and then we're pivoting with some trigonometry around that point. So I'm going to call that good for now. And when we come back in part 2, we'll actually go about drawing the shapes. Thanks for hanging in there if you made it all the way, 25 minutes.